Okay, so this is for chapter 24, and it has to do with charges on capacitors. It's important to note that there's different kinds of capacitors. You have capacitors that are in series, and you have capacitors that are in parallel. Parallel capacitors have special thing, and in series have their own little thing going on. So, okay, so the first thing that I did was redraw it because this here looks ugly. So I redrew it like this, in which 41, these two would be parallel capacitors. So then I just redid this again with a capacitor equivalent. Capacitance, equivalent capacitor in parallel capacitors is simply the sum of the capacitor. So if this is a capacitor of 16, this is a 41, then it's 41 plus 16, and that's 57 micro farad. That would be my capacitor equivalent that I have right here. And I've let this stay the same. Now, these capacitors are said to be in series capacitors, and capacitors in series share the same charge. So you can essentially make that an even smaller with a C equivalent. And then using the voltage drop, you can find the charge on that C equivalent. And the charge on that C equivalent is going to be the charge of that 21 capacitor, which is exactly what I did. So I did use the equation for a capacitor equivalent in a series, which is just 1 over the capacitors. So 1 over C1, 1 over C2, and 1 over C3. Remember that this is my C equivalent that I calculated here, but it counts because we're counting it as just the one capacitor. My C equivalent turned out to be 10.47 microfarad. And let me just redraw what the structure would look like, or what I would think the structure would look like. And this would be my C equivalent for this series, and it would be 10.47. So then to calculate the charge going through it, it's just your simple equation, which is up here. Your voltage is Q over C, or your charge is your voltage across AB. Oh, you guys can't see it? Why can't you guys see that? I'm so sorry. Okay. Okay. So this is the voltage equals Q over C. Your charge is your voltage times your capacitor. The capacitor in this case is the capacitor equivalent that we calculated towards the very end. This 10.47, this one right here. We plug everything in and we get a capacitance of 125 microcoulombs. That would be the charge on this 21 microfarad capacitor.